In this presentation, I'm going to go over how solar panels and inverters work together to provide a home with a net metered solar system. Also details about the products we use as a company and how to decide what type of product to use on your home. How solar works is the solar electric panels produce DC current. That DC current is then pushed through a device called an inverter. The inverter converts the DC current that is flowing through it into AC current. AC current is the same type of current the electric grid runs on. After the inverter converts the DC current to AC current, the energy then flows through the main electrical panel located on your house and backfeeds the utility grid. The system backfeeds the utility grid, and the homeowner then becomes a distributive energy generator, meaning that the energy you backfeed into the grid is not specifically used in the home the system is located on. If the utility company's grid goes down, then the homeowner with the solar system will be without power. We'll be going over backup power on a different presentation. Maguey Solar is a solar panel manufacturer that we prefer to use. The reason we like this company is that they have 40 years of experience. And they didn't start in manufacturing solar panels. They actually started in manufacturing roofing attachments and aluminum extrusions. So they've grown over the past 40 years into a company that has 30 facilities worldwide, and they have 5 different branches of their organization, one of which is solar photovoltaic manufacturing. Another reason that we like Maguey Solar is that they didn't get into business just to manufacture solar. We've seen solar panel manufacturers come into business just to manufacture solar panels and go out of business manufacturing solar panels. So Maguey Solar has been around for a long time, meaning that the warranties they're placing on their product is a little more secure than a new company coming in to manufacture just solar panels. It's a German company, so it's German engineered. They do have a manufacturing facility here in America, in Georgia. Their other 3 locations that they manufacture solar panels is Italy, Spain, and South Korea. They do offer the highest output power guarantee in the solar industry. Canadian Solar is another solar product that we'll use. Canadian Solar is a Chinese manufactured product. So what that means is basically it's going to be a lower cost option for an end user. They do have a very good warranty. It's 25 years. Even though the company was started in 2001 in Canada and outsourced their manufacturing to China, they have a third-party insurance policy on all of their modules that are installed in the U.S. So we like this product line at a lower price point with that added value of having third-party insurance for the warranty. Solar panels have long warranties because of the products that they are made with. The core of the panel has silicone wafers and electrical connections, and what protects those fragile components is a silicone encapsulant. Silicone encapsulant has been used in building materials for over 60 years and has stood up to the test of time. And then what's layered over that material is a backing plate and low iron tempered glass. The panel comes together with its aluminum frame, which surrounds the edges. The warranties for the Maguey product is a 30-year power guarantee. And how that guarantee works is at year 1, you get 100% of the guaranteed power. The panels will degrade slightly over time at 0.008% per year. So at year 12, you'll get 90% of the guaranteed power that you would have gotten at year 1. And then at year 30, you'd get 80% of the power that you would have received at year 1. The positive watts tolerance that's reflected, how that works is the product comes out of a manufacturing facility and is tested. It's a flash test, which determines the actual output of the panel. So every panel that comes off the line is rated at +5 of the stated wattage. So if you had a 285 watt panel that is flash tested at +5 watts, then you have a 290 watt panel. So in comparison to the Canadian Solar module that I showed you on the last slide, in the Maguey Solar warranty, you can see that the power guarantee is going to be 25 years, and that is industry standard, not just Canadian Solar, but All other Tier 1 products have a 25-year power guarantee, a 10-year 90% power guarantee, a 25-year 80% power guarantee, and then there's a variance between the different solar panel manufacturers for their positive tolerance, which is going to be anywhere from plus or minus 2 to 7%. This is a DC inverter by SolarEdge. Solar Solution AZ utilizes this brand because they have innovative technology and great support. We reference the brand because it is what we currently recommend, but we are not opposed to working with other product brands like SMA, Solivia, or Fronius, which are other tried and true inverter lines. So what we're looking at with DC inverters is maximum inverter efficiency, and on average, DC inverters are going to convert about 98% of the energy that could be converted going into it. So this is an Enphase microinverter. What we're specifically looking at is the inverter efficiency for a microinverter. And you can see that the peak inverter efficiency is 96.5%. We'll go over a little more how microinverters work versus how DC inverters work later on in the presentation. The reason we show you Enphase is Enphase has the #1 market share for microinverters in the world. Over 50% of microinverters that are being installed today come from Enphase, and it's because their technology is just better than everybody else's. This is a SolarEdge Power Optimizer by SolarEdge. This device works in conjunction with the DC optimizer, and what we're specifically looking at is the efficiency, the superior efficiency of 99.5% to convert the energy that flows through it. So what occurs in the morning when the sun comes up is there's rays of light that are coming across our solar panels, creating what's called horizontal shading. When the sun reaches the middle of the day, you can see that there is no horizontal shading. And then when the sun sets at night in the west, you can see again that the rays come in and cast horizontal shading over our array. So the topic is how the inverters convert energy when there's horizontal shading. So a string inverter, the panels produce this amount of energy when there's horizontal shading. And in this example, it shows 95, 96, 97, 98, 100. The panels are connected in series, and the panels can only operate at the lowest performing point. So the array can only convert this amount of energy, the 95, that's the lowest performing point. Then the string inverter can convert this amount of energy at 98% efficiency. So when there's horizontal shading in the morning for a microinverter, the panels produce the exact amount of energy they possibly could, and the microinverter can convert this amount of energy at 96% efficiency. The string inverter paired with the DC optimizer operates similar to the microinverter. The amount of energy that the panels produce, it can convert all of that energy, but at a higher percentage, and that percentage is 99.5% efficient. We're looking at the characteristics of a DC inverter from daybreak to horizontal shade break, so 3 hours in the morning when there's horizontal shading, and exactly what that inverter will convert as far as energy is concerned. So you can see that we have our panels laid out, 96 watts per panel, 5 panels, gives us 480 watt hours per hour. Over 3 hours is going to give us 1,440 watt hours converted at 98%, gives us our adjusted figure of 1,411, which converts into 1.4112 kilowatt hours. So the microinverter, its conversion ratio at daybreak to horizontal shade break, still 3 hour time frame. We're looking at the panel 1, 2, 3, 4, 5 for the same amount of time as the other inverter. I have all the formulas outlaid, and we still come up with the same exact power. Why that happens is because this inverter is less efficient, although it does provide more individual power from each panel at the time of sunlight. What it doesn't do is convert the energy more efficiently. So we get a wash from the DC inverter to the microinverter for the amount of power that it actually produces. The DC inverter with optimizers throughout that same time period from 6 a.m. to 9 a.m. Is going to produce slightly more energy than both the inverter, the DC inverter, and the microinverter. So in conclusion, for converting the most energy, the DC inverter with optimizers will convert the most energy on a day-to-day basis. So in conclusion, to inverters, you now have the facts about the conversion of inverters. String inverters have been around for over 20 years and are a proven technology. Microinverters are a good idea, but we still see a lot of these devices failing. Why they fail: there's more components in line with each other, the heat in Arizona, and the individual conversion point with circuitry that can overheat. We leave the decision up to you and how you want to convert energy for your project.